In this video, we will introduce buffers that are typed within the java.nio package for the Java programming language. A buffer is essentially an array, usually of bytes, but other kinds of arrays can be used. The buffer interface offers byte buffer, char buffer, int buffer, short buffer, long buffer, float buffer, and double buffer that holds some data to be written or that was just read. Byte buffer has essential properties like limit. When writing from a buffer, the limit specifies how much data remains to get. When you are reading into a buffer, the limit specifies how much room remains to put data into. Position. The position keeps track of how much data you have read or written. It specifies into which or from which array element the next byte will go or come. A buffer's position is never negative and is never greater than its limit. Capacity. The capacity specifies the maximum amount of data that can be stored in a buffer. The limit can never be larger than the capacity. Let's take a look at an example so we can learn how to use these buffers. To create a buffer, you can use the allocate_in_capacity method. Each buffer object has the allocate_in_capacity method. When calling this method, you need to pass the value of the capacity of the buffer to be created. Here we have an example of each typed buffer. Now we will use a buffer to show how to use some of the functions in the java.nio.buffers class. We create a buffer and then using the asInt method for our buffer, we create a view of this byte buffer as an int buffer. Here we use the relative bulk method to put or add values to our buffer. In the following line, we print out our absolute location of the value in position 3. Here we use an absolute put method, replacing 3 with 2013. The rewind method sets the position to 0 again, in case you want to make the buffer ready for another draining. Our while loop demonstrates that buffers can be drained into any data type. We use the method hasRemaining, which tells us whether there are any elements between the current position and the limit. We will loop until we get to 0. We will use the method get to transfer an int from an associated buffer into an actual int. In the end, we'll print this to the console. Let's run our program and see our output. Here we can see the contents of our buffer. Our absolute location value. We replace 3 with 2013. The position 3, 0, 1, 2, 3, which in this case would be the value of 12. This concludes our discussion of buffers that are typed in Java.